So graphing quadratic functions in transformational, also known as vertex form. So our learning target is we can graph quadratic functions in these forms, which we have seen before, f of x equals a times the quantity x minus h squared plus k. So notice that there's a squared here instead of having the absolute value lines. We want to show the vertex, axis of symmetry, zeros, which is also our x-intercepts, y-intercept and points via symmetry. Okay, so this is our third major function family. We've done linear before, we've got absolute value, which we've just finished, and now we're going to talk about quadratic functions. So quadratic functions. So before we graph the parent function, there's some important piece of information we've got to learn about quadratics. So a quadratic is a polynomial of degree 2, since the highest power, or the exponent of x, is 2. Basically, you'll be seeing x squared. In transformational form, you see this 2 right here. There are three major forms of quadratic function. We've got transformational and vertex form, which we'll talk about today, standard form, and then intercept form. So the shape of a quadratic is called a parabola. You've seen before, a parabola, which is U-shaped. The U shape can either be opening up or opening down. So if a is positive or greater than 0, the parabola opens up. If a is less than 0, i.e. it's negative, the parabola opens down. So if we see negative 3 times the quantity x minus 2 squared, this will open down because of the negative in front of the a. And if we had 1/2 x plus 3 all squared minus 5, this would open up because the a value is positive. Okay, the most important point on the graph of a quadratic is the vertex, which is the middle of the graph. So let's start by graphing the quadratic parent function. We'll have x squared. So if you think about this in transformational form, we have, it would be written as a times x minus 0 all squared plus 0, where a, in this case, we would replace with a 1. That would mean that our vertex is 0, 0. So we're going to put this in the center of the graph, as written here, it's the center of the graph. And then we just choose values either side of this. So negative 1, negative 2, negative 3. And then we can do 1, 2, and 3. And we're simply putting these values into this function. So we're writing it as negative 3, and that squared would give us positive 9. Negative 2 squared is 4. Negative 1 squared is 1. Then we put in 1, that's also 1. 2 squared is 4, and 3 squared is 9. If we found our vertex correctly, these y values will match up because they're reflected across what's called the axis of symmetry. Let's go ahead and plot these points on our graph here. So we've got negative 3, and that goes up to 9. We've got negative 2 and 4, negative 1 and 1, 0, 0, 1, 1, 2, 4, 3, 9. Now we can also do the points positive 4 and negative 4. When we square 4, we get 16. When we square negative 4, we also get 16. And we can plot those values also. And then we have this nice parabolic shape, or a U shape. Okay. So, looking at this shape, we have what's called an axis of symmetry, where the line reflects across. Let me just draw this in here. If I was to take a mirror, or a mirror, and draw a line down here, we could see that it would reflect across this vertical line. And that vertical line is written as x equals 0. We can see here the equation is x equals a number, and it passes through the vertex. Our y-intercept for the parent function is 0, 0. 0y, in general, point where the graph crosses the y-axis. The x-intercepts, the points where the graph crosses the x-axis. In this case, it's just going to be one of them, 0, 0. A lot of time we'll have 2, and some of the time we'll have none. The domain, so how far left and how far right. We've got negative infinity to positive infinity. The range is going to be from the lowest value to the highest value, so from down here going up. So that's going to be from 0 to infinity. Now, this value is on the graph, so it has to be a bracket. It's also asking, is this a maximum or a minimum? Well, since it's down here, this is a minimum value. We're looking for that y value, which is going to be 0. Okay, and then a couple more things. Transformational and vertex form where a is your quadratic coefficient. This determines if it opens up or down. H is the x-coordinate of the vertex, which you've seen before. K is the y-coordinate of the vertex, which also we've seen before. We're really good at finding the h and the k. What we'll have to work on with quadratics is what this a does to the graph. It does the exact same things, but it's going to be slightly different from absolute value. So step 1, we're going to find or identify the vertex from the equation, which we should feel really good about doing. I'm going to make an xy table choosing x values either side of the x value of the vertex. In step 3, put all the information onto the xy axis and sketch the graph as a function.